In January 1941, Charles Sorensen stood beneath the bright California sun at Consolidated Aircraft's San Diego facility, watching workers assemble B-24 Liberator bombers under conditions that made his teeth clench. Sorensen was Ford Motor Company's production chief, 60 years old, a Danish immigrant, hard as railroad iron. He had been with Henry Ford since 1905, starting as a $3-a-day pattern maker and rising to become the man who actually built the moving assembly line that changed the world. If anyone alive understood mass production, it was Charles Sorensen. Standing beside him was Edsel Ford, the company president, 45 years old and Henry Ford's only son. They had flown from Detroit to observe how Consolidated was building the bomber the Army Air Corps desperately needed. What Sorensen saw made him want to leave immediately. The bombers were being assembled outdoors, exposed to the California sun. Workers attached engines to airframes using improvised rigs. Heat warped metal components out of tolerance. Nothing was standardized. Every aircraft required constant fitting and refitting because no two parts were exactly the same. Consolidated had a contract to build the bombers, yet after months of effort they had completed only 7 aircraft and delivered just 3. Across the Atlantic, the war in Europe was destroying entire nations. France had fallen. Britain was being bombed night after night. President Franklin Roosevelt had called on American industry to produce 50,000 combat aircraft to confront what he described as the gathering storm of global war. That figure exceeded the total number of airplanes built in the United States since the Wright brothers flew at Kitty Hawk in 1903. Consolidated could not even complete 8 bombers in 6 months. The Army Air Corps had brought Ford into the program, hoping the automotive giant would manufacture parts and subassemblies, components only to be shipped to Consolidated for final assembly, the standard procurement approach. But Sorensen stood there watching grown men struggle to attach wings that did not quite fit onto fuselages warped by the sun, and he knew the plan would never succeed. The B-24 was a complex machine, 67 feet long, a wingspan of 110 feet, 4 engines, a crew of 10, and roughly 1.5 million individual parts. A Ford automobile contained about 15,000 parts. This bomber was 100 times more complex. Every aviation expert in America insisted that airplanes could not be built the way cars were built. There were too many variables, too much precision required. Each aircraft was essentially custom-made. But Sorensen saw something the aviation experts did not. He recognized the same fundamental manufacturing problem he had solved 2 decades earlier with automobiles. Move the product, not the workers. Standardize components, create sub-assemblies, and feed them to a main line at precise intervals. Simple physics, simple logistics, massive output. That night in his hotel room, Sorensen could not sleep. His mind raced with calculations, layouts, and workflows. He grabbed hotel stationery and a pencil and began sketching. He broke the B-24 down into major assemblies, fuselage, wings, tail section, landing gear, engines, and then divided those into subassemblies, wing sections, engine mounts, control surfaces. 69 subassemblies in total, each built on its own line, each feeding into the main assembly at exactly the right moment. He sketched a plant layout more than a mile long, with 2 parallel assembly lines, raw materials entering one end and finished bombers exiting the other. 1 aircraft every hour, 24 hours a day, 7 days a week. At breakfast the next morning, Sorensen showed Edsel the sketch and explained the concept. 1 bomber per hour was a preposterous claim. Consolidated took weeks to build a single aircraft. Sorensen was proposing 1 every 60 minutes. Edsel studied the pencil drawing, looked at Sorensen, and said Ford Motor Company would build such a plant. That afternoon they met with Consolidated's executives. Sorensen laid out his plan. The aviation specialists listened politely, then dismissed it as impossible. Aircraft were not automobiles. You could not standardize complex bombers the way you standardized simple cars. The tolerances were too tight, the engineering too sophisticated. Mass production worked for Model T Fords, they argued, but it would never work for 4-engine heavy bombers. Sorensen asked them a direct question: how would you do it? They had no answer. Their outdoor, craft-based assembly process was all they knew. It was slow and inefficient, but it was how airplanes had always been built, one at a time by skilled craftsmen. Sorensen told them Ford would not merely build parts. Ford would build complete aircraft on a moving assembly line at automotive production rates. The Army would get its 50,000 airplanes, but not the Consolidated way, the Ford way. The meeting ended badly. Aviation executives believed Sorensen was arrogant, that he did not understand their industry, and that he would fail spectacularly while wasting government money. They filed reports saying exactly that. What they did not know was that by the time Sorensen returned to Michigan, he had already committed Ford Motor Company to the largest manufacturing gamble in American history. The cost of slow bomber production was measured in missed opportunities and delayed operations. In 1941 and early 1942, the Army Air Forces faced a critical shortage of heavy bombers. Training units flew obsolete aircraft because new production could not keep pace with demand. Combat units deployed overseas with fewer airplanes than their tables of organization required, limiting their effectiveness. The strategic bombing campaign against Germany, central to American war plans, could not begin in earnest until sufficient bombers were available. British forces were conducting night raids at terrible cost. American doctrine called for daylight precision bombing, but that required massive formations for mutual defense, and massive formations required hundreds of aircraft. In all of 1941, American factories built fewer than 2,000 heavy bombers. Germany, meanwhile, was producing war material at full industrial capacity while America struggled to field enough aircraft to fight effectively. General Henry Hap Arnold, commanding the Army Air Forces, knew that at existing production rates the United States would not have enough bombers for sustained strategic campaigns until late 1944. By then, the war might already be decided. As these pressures mounted, construction crews were tearing apart Henry Ford's farm. The site Sorensen selected covered 1,875 acres of Ford-owned land near Ypsilanti, Michigan. It had been Camp Willow Run, a summer farm camp for boys whose fathers had been killed or disabled in World War I. Henry Ford ran it as a character-building operation. Boys lived in tents, rose at 5:30 a.m., attended church before breakfast, and worked the fields all day. Ford believed hard labor built men. Now bulldozers were leveling the woodland. 300 men with saws, axes, and heavy equipment attacked the 100 acres where the plant would stand. A steam-powered sawmill from Ford's Greenfield Village Museum converted felled trees into 400,000 board feet of lumber. Fields were cleared and graded for construction. Henry Ford despised the project. At 77 years old, he was increasingly unpredictable and fiercely isolationist. He had opposed American involvement in World War I, and now another European war was pulling the United States toward intervention. Ford wanted no part of it. He initially refused government requests to build military equipment and forced Edsel to cancel contracts for aircraft engines destined for Britain. Edsel eventually convinced him that this was different, that this was about defending America. Despite his isolationism, Henry Ford ultimately agreed, partly because Edsel pressed the case, partly because Charles Sorensen convinced him the engineering challenge was worth solving, and mostly because Henry Ford could never resist proving people wrong. Every aviation expert in America said the plant would fail. Architect Albert Kahn designed the structure. Kahn, who had designed the River Rouge complex and hundreds of other industrial facilities, declared that Willow Run would be the largest room ever built by man. He may have been right. The main building measured 3,200 feet long and 1,279 feet wide at its widest point, encompassing 80 acres of interior space, 20% larger than the total floor area of the Empire State Building. It was a single-story structure with no interior support columns, a vast open factory floor stretching more than a mile. The layout was L-shaped. According to folklore, Henry Ford insisted the eastern perimeter not cross into Wayne County, home to Detroit Democrats and union organizers. Whether true or not, the L shape created a serious engineering challenge. The assembly line had to turn 90 degrees near the end. Sorensen solved the problem by installing two massive turntables that rotated completed fuselages through the bend. Construction began on April 18, 1941. 5 major contractors worked simultaneously as the building rose in sections. Workers erected plywood partitions to isolate completed areas from those still under construction. Production equipment was installed in finished sections while construction continued elsewhere. The first portions of the plant opened for production in September 1941, 3 months before Pearl Harbor. What followed was 20 months of spectacular failure. The aviation experts had been right about one thing: building bombers was not like building cars. Consolidated Aircraft retained design authority, as did the Army Air Corps, and Ford had no power to change anything. Consolidated could call Willow Run at any time and demand modifications, and they did, often several times a day. Sorensen dispatched 70-man teams of Ford engineers to San Diego to learn everything about B-24 construction. They discovered that the engineering drawings were useless, unfinished, inconsistent, filled with errors, and covered in unfamiliar symbols. Many specifications existed only in the memories of consolidated foremen. Sorensen had 2 Liberators flown to Dearborn and dismantled them piece by piece. His engineers created complete drawings based on the actual aircraft. 200 engineers worked around the clock, 7 days a week, producing what became known as 5 miles of drawings every day. They worked in shifts, day crew and night crew, creating the documentation Consolidated should have supplied from the start. Of the 30,000 drawings they produced, 10,000 were obsolete before they ever reached the production floor because Consolidated kept changing the design. The B-24 was evolving rapidly. In 1941 and early 1942, the Army Air Corps was learning through combat what worked and what did not. They demanded more defensive armament, improved turrets, modified bomb bays, and better engines. Each change made the aircraft more capable and made mass production that much harder. Each modification disrupted Ford's assembly line. Every change required retooling. Ford's mass production system demanded fixed specifications, standardized parts, identical aircraft, but Consolidated modified the B-24 constantly. The B-24A became the B-24C, the C became the D became the E. New gun positions, different turrets, redesigned tail assemblies. The B-24E, the first model Ford built in quantity, had a power-operated top turret. The earlier models didn't. That meant new tooling for the fuselage opening, new electrical systems, new hydraulic lines. Ford engineers designed the tools, installed them, trained workers, started production, then Consolidated announced changes to the E model. The modification that caused the most disruption came in mid-1942. The Army wanted a nose turret for frontal defense. The B-24 had been designed with a greenhouse nose for the bombardier. No turret. German fighters had learned to attack head-on where American bombers had the least defensive fire. The nose turret was essential. It was also a complete redesign of the aircraft's forward structure. Ford engineers had to redesign jigs, tools, and assembly procedures for the entire forward fuselage. The work took months. While they redesigned, production slowed to a crawl. When the new jigs were ready, workers had to be retrained. The first B-24H models with nose turrets didn't leave Willow Run until late June 1943, 10 months behind schedule because of one modification. The first bomber took 10 months to build. It rolled off the line October 1, 1942. Workers christened it the Spirit of Ypsilant. It was supposed to have been completed in May. Newspapers that had praised the project started calling it Will It Run. Willow Run became a national joke. The massive factory that was supposed to prove American industrial superiority was producing almost nothing. In all of 1942, Willow Run built 56 complete aircraft. Most were actually assembled by Consolidated or Douglas in Oklahoma and Texas from Ford produced sub-assemblies. The mile-long assembly line barely functioned. Workers couldn't get to the plant. The facility was 25 miles from Detroit. Wartime rationing, limited gasoline and tires. Public transportation was inadequate. Rural roads connecting Ypsilant to Detroit were two-lane highways designed for light traffic. Now thousands of workers tried using them simultaneously. 4 shift changes. In 1 month, Ford hired 2,900 workers, lost 3,100. People took jobs, worked a week, discovered the commute was impossible, quit. The turnover rate was devastating. More workers quit than were hired. The plant was losing workforce faster than recruiting could replace them. Those who stayed found working conditions miserable. The factory had started production before construction finished. Half the building had no heat in winter. Michigan temperatures dropped below zero. Workers wore heavy coats while assembling precision aircraft parts with frozen hands. Condensation from body heat froze on metal surfaces. Tools were so cold they stuck to bare skin. In summer, conditions reversed. The massive factory had no air conditioning. Temperatures inside reached 100 degrees. Workers collapsed from heat exhaustion. The factory floor was metal and concrete. It radiated heat like an oven. Fans moved hot air around but didn't cool anything. Labor turnover exceeded 100% annually. Training took weeks. New workers spent their first month learning basic aircraft assembly. By the time they became proficient, they'd quit. New workers replaced them. Needed training, quit before becoming productive. The cycle repeated endlessly. Experienced workers were training replacements who would never stay long enough to become experienced themselves. Absenteeism ran 20 to 30% daily. Workers called in sick, went to work at other Detroit factories.
With better conditions, better pay, easier commutes, Ford couldn't fire them. Every company in Detroit was desperate for workers. Fire someone at Willow Run, they'd have a new job by afternoon, probably making more money.
The housing crisis became critical by late 1942. Workers were sleeping in cars, renting
rooms in shifts. 3 men sharing one bed, one worked days, one worked nights. One worked swing shift.
The bed was never empty.
Landlords charged double and triple rent.
Why rent to one family
when you could rent the same space to 3 different shift workers who'd never be there at the same time? The federal government finally stepped in. In February 1943, the first dormitory opened, Willow Run Lodge.
15 buildings containing 1,900 rooms,
some single occupancy, others double. Space for 3,000 people. It wasn't enough. Between June and December 1943, construction crews built temporary buildings for 2,500 families. Willow Run Village, 4, 6, or 8 apartment flat tops, 1, 2, or 3 bedrooms. The West Court buildings had peaked roofs.
Some had no bedrooms, called zero-bedroom apartments, essentially large rooms with kitchens and bathrooms.
Couples lived there. 3 adults could share one. A trailer park followed. 1,000 mobile homes, community laundry
facilities, shared shower and toilet buildings. Workers bought or rented trailers, parked them in rows, lived there for the duration.
Some trailers had been summer vacation campers.
Now they were year-round homes for families
with children. Another dormitory, West Lodge, added 1960 rooms in August 1943. By the end of 1943, 6 different temporary housing projects surrounded
Willow Run, 2 dormitories, 2 trailer parks, 2 family housing complexes. Together, they sheltered more than 15,000 people, roughly equal to the entire population of Ypsilanti at that
time.
The government built parkage homes separately in 1943 for African American workers.
Willow Run Lodge and Village were segregated.
The Detroit Housing Commission and National Housing Agency refused to integrate
them.
Noted African American architect Hillard Robinson designed Parkridge, 80
units, separate but theoretically equal. In practice, fewer units for black
workers than white workers despite similar workforce percentages. Then Senator Harry Truman came to
investigate. Truman headed the Senate Special Committee to investigate the National Defense Program. His job was eliminating waste in military contracts. Willow Run's problems had reached Washington. Truman arrived in April 1942 to see if the government should nationalize Ford Motor Company and take over the plant. L. Ford met him
personally, explained the design change problem, showed him documentation. Every day, sometimes multiple times daily, Consolidated called with modifications.
Each change cascaded through the production system, causing delays, requiring expensive retooling. Truman wasn't interested in excuses. He wanted finished bombers. The investigation continued into February
1943. Truman toured the facility again, saw the massive empty building, the barely moving assembly line, the handful of aircraft being built, but his committee's final report cleared Ford. The delays weren't the company's fault.
Consolidated's constant meddling was preventing production. The committee gave Willow Run a clean bill of health, then recommended that one person be given complete authority over the program. No more design changes, no more interference from Consolidated. 1.
Manager, total control. Production began climbing slowly at first, then with
increasing momentum. 37 complete aircraft in January 1943,
70 in February, 96 in March, 146 in April.
The numbers told the story. Willow Run was finally working. The transformation wasn't magic. It was systematic problem solving. Every bottleneck identified and fixed. Every delay analyzed and eliminated. Every inefficiency improved.
The Truman Committee's investigation had forced changes. One manager, Bicker, was given
authority over the entire program. No more divided responsibility. No more conflicting orders. One person made decisions. Everyone else followed them. Consolidated design changes slowed then stopped. The Army Air Forces standardized on the B-24J model in Spring 1944. Final design. No more modifications. Build this version and only this version. That standardization was what Ford needed.
Fixed design meant tooling
Could be perfected instead of constantly changed.
The workforce stabilized.
Housing projects meant workers could actually live near the plant. Commute times dropped. Absenteeism dropped.
People stayed in jobs long enough to become skilled.
Skilled workers trained new workers more efficiently. The
training cycle stopped being a treadmill. The production line itself evolved.
Ford engineers made hundreds of small improvements.
Better tool placement, more efficient part delivery, improved lighting, better work
platforms. Each change saved seconds. Multiply those seconds by thousands of
workers doing millions of tasks, and the time savings became massive.
By autumn
1943, the plant was producing at rates that seemed impossible 18 months earlier.
The 1000th bomber, celebrated November 3rd, represented a turning point.
From joke to miracle in
less than a year, but that success came at a price. Adele Ford never saw the plant reach its full potential.
His health had been deteriorating for months. The stomach pain he'd been ignoring wouldn't stop.
In January 1942, surgeons operated, found metastatic cancer, inoperable.
They closed him up and told him he had months, maybe a year.
Needle worked anyway.
Through pain, through the knowledge he was dying, through radiation treatments that made him sick. He'd made a promise, 1 bomber per hour. He was going to see that promise kept.
He attended meetings when he could barely walk, reviewed production reports from a hospital bed, made decisions about tooling modifications while recovering from treatments.
His staff begged him to rest. He refused.
Willow Run needed him.
The stress undoubtedly accelerated the cancer's progression.
Medical historians agree on this.
The constant pressure, the battles with Consolidated, the fights with his father, the government scrutiny, the
media criticism, all of it wore him down.
The cancer was killing him anyway. The stress made it kill him faster.
Henry Ford didn't understand. Thought Adele just needed rest. Thought a chiropractor could cure him.
Couldn't accept that his only son was dying of a disease that medicine couldn't stop.
Henry's denial made things worse. Added guilt to Edel's burden.
His father thought he wasn't trying hard enough to get better.
Ellen Ford, Edsel's wife, watched him deteriorate, watched the pain increase, watched the treatments fail, watched her husband sacrifice himself for a factory. She later said,
"The project killed him, the cancer was there, but Willow Run accelerated everything."
Adele Ford died at home in Grosse Pointe Shores at 1:10 in the morning on May 26, 1943, age 49.
The stress of Willow Run had consumed the last 18 months of his life. His funeral was May 28. Thousands attended, business leaders, government officials, Ford employees.
The entire Willow Run workforce shut down for the day.
Workers lined up outside the church.
Too many to fit inside. Henry
Ford was devastated. Lost without his son.
6 days after the funeral, he announced he was reassuming the presidency of Ford Motor Company.
The board was horrified.
Henry was 79 years old, clearly in mental decline, physically weak. He sometimes didn't recognize his own executives, but he
owned the majority of the stock.
Nobody could stop him. The government panicked.
Ford Motor Company was building bombers, jeeps, tank engines, aircraft engines.
Critical war production depended on Ford. The company couldn't be run by someone who might not remember what year it was.
Secretary of War Henry Stimson spoke with Ella Lanina Ford, explained
the situation.
The country needed Ford Motor Company functional.
Someone competent had to run it. Ella Lanina agreed. She and Clara Era Ford, Henry's wife, together convinced Henry to step aside. Edsel's son, Henry Ford II, was pulled from Navy service, came home,
took over the company September 21, 1945, 28 years old.
No business experience. Suddenly running one of America's largest corporations during wartime. Young Henry had to learn fast. The company was chaotic.
His grandfather had let things deteriorate.
Management was a mess.
Only the production side, run by Sorensen and his team, functioned
well. The rest of the company needed complete reorganization. Young Henry watched Willow Run hit its peak. Production rates in spring and summer 1944. Watched his father's promise finally kept. One bomber every 63 minutes. Edsel never lived to see it, but his son did. Young Henry made sure everyone knew this was Edsel's achievement, not Henry Sr.'s, not Sorensen's alone.
Edsel's. The price had been Edsel's life, but the achievement was real. Willow Run worked. The promise was kept. The center wing was the structural heart of the aircraft. It connected the two outer wing panels, housed the main landing gear, contained the bomb bay, and supported all four engines. Everything attached to the center wing. Get it wrong and nothing else would fit correctly. Consolidated built each center wing using a temporary wooden jig. The jig was a precisely shaped framework that held the wing ribs, spars, and skin panels in correct alignment while workers riveted them together. Build the wing inside the jig. Rivet everything, remove the finished wing, throw away the jig, build a new jig for the next wing. Each jig took 250 man-hour to construct. Skilled carpenters built them from templates. Every measurement had to be perfect. Any error in the jig meant errors in the wing, and errors in the wing meant the aircraft wouldn't fly correctly. The jigs were single use. After one wing, they were scrap lumber. Ford engineers looked at this process and saw waste. 250 hours of skilled labor producing something used once and discarded. That wasn't mass production. That was custom craftsmanship. They designed a permanent steel jig, heavy framework made from precision machined steel members. The jig could handle multiple wings without warping or wearing. Move wing structure in with an overhead crane. Complete all assembly work while the structure sat in the jig. Remove finished wing with crane. Insert next wing structure. Repeat. The permanent jig took weeks to design and build. It cost significantly more than wooden jigs, but it could be used indefinitely. More importantly, it was precisely machined. Every wing built in that jig would be identical to every other wing. Perfect standardization. The first permanent jig reduced center wing assembly time from 250 man-hours to 1 man-hour. One person could install wing ribs into the jig in the time it previously took 250 carpenters to build. A throwaway jig. Ford built multiple permanent jigs, positioned them along the assembly line. Wings moved from station to station. Each station added specific components. Ribs at Station 1, front spar at Station 2, rear spar at Station 3, skin panels at Station 4, fuel tanks at Station 5, landing gear attachments at Station 6, inspection at Station 7. The process became so efficient that by late 1943, center wing assembly was the fastest section of the entire production line. What had been the biggest bottleneck became the pace setter. The permanent jig innovation spread to other assemblies: fuselage jigs, tail section jigs, engine nacelle jigs. Every major component got permanent tooling instead of throwaway jigs. The time savings compounded across the entire assembly process. On November 3, 1943, workers celebrated the 1,000th finished B-24. One person who should have been there wasn't. Edsel Ford had died 6 months earlier. By autumn 1943, leadership at Willow Run passed from Charles Sorensen to Me Bricker. The government requested Ford decentralized operations. Many sub-assemblies moved to other Ford plants and subcontractors. Willow Run concentrated on final assembly. The bugs were worked out. The design changes stopped. The workforce stabilized. Housing was built near the plant. Dormitories for single workers. Apartments for families. Willow Run village 15,000 people larger than the city of Ypsilanti. Women flooded into the factory as men were drafted. By May 1942, 15% of the Willow Run workforce was women. That percentage climbed steadily. By summer 1944, thousands of women worked at Willow Run. They filled every role except the heaviest physical labor. Women worked as riveters, the most critical skilled position in aircraft assembly. Riveting required precision. Drive the rivet too hard, you crack the aluminum skin. Too soft, the rivet doesn't hold. Perfect pressure, perfect angle thousands of times per shift. Women became experts. They worked as welders. Spot welding, arc welding, gas welding. Joining. Aluminum parts required different techniques than welding steel. Aluminum melts at lower temperatures, conducts heat faster, warps easily. Women learned the skills, passed the qualification.
tests, worked alongside men doing identical jobs. They worked as mechanics, installing engines, mounting propellers, connecting control cables, hydraulic systems, electrical systems, fuel systems. Every system in a B-24 had to be installed, tested, adjusted, and inspected. Women did all of it. They worked as inspectors. Quality control was critical. Every rivet had to be checked. Every weld had to be tested. Every system had to function perfectly. An aircraft with faulty rivets would come apart in flight. Women inspectors caught defects before aircraft left the factory.
They earned the same wages as men for the same jobs.
Ford had mandated equal pay. A woman riveter made the same hourly rate as a male riveter. A woman mechanic made the same as a male mechanic. This wasn't universal in wartime industry. Many factories paid
women less than men for identical work.
Ford didn't. Rose Will Monroe became
one of the most famous Willow Run workers. She worked as a riveter on the night shift.
Drove rivets into B-24 fuselages.
In 1944, actor Walter Pidgeon toured Willow Run for a promotional
film. He saw Monroe working. She fit the image the War Production Board wanted for recruitment posters. Young woman.
Attractive, clearly competent, doing traditionally male work.
Monroe appeared in promotional materials for war bonds.
Some sources claim she inspired the Rosie the Riveter character, though this
is disputed. Multiple women named Rose worked in war industries. Several appeared in promotional materials. The iconic Rosie image was already established before Monroe's publicity.
Whether she inspired the character or simply fit an existing image remains unclear.
What's certain is that thousands of women worked at Willow Run.
They learned skills most had never imagined learning.
They earned wages most had never earned before.
They built bombers that flew in combat.
Knowing their work directly supported the war effort. Many had husbands, brothers, sons in uniform. Some were flying the
same aircraft these women built.
That knowledge drove quality. Every rivet mattered. Every weld mattered. Bad work meant someone's son might die. Good work meant someone's son might survive. After the war ended, most women workers were laid off. The men came home from service, took back the jobs. The social expectation was that women would return to domestic life.
Many did, but thousands had learned they could do work they'd been told was impossible for women.
That knowledge didn't disappear. The skills didn't disappear. The women
who worked at Willow Run became nurses, teachers, business owners, factory
supervisors. They'd proven to themselves what they could do. That proof changed
lives, changed families, changed expectations for their daughters.
The production rate climbed steadily, then explosively. In 1944, Ford was rolling a Liberator off the Willow Run production line every 63 minutes, 24 hours a day, 7 days a week. Peak monthly production came in April 1944. 453 complete bombers, more than
Consolidated, had built in all of 1941.
Between April 24 and April 26, 100 completed bombers flew away from Willow Run. 33 aircraft in 48 hours. The
transformation from joke to miracle had taken less than a year.
What neither Sorensen nor anyone else at Ford fully
understood was how this terrified Germany.
German forces experienced the results firsthand. Every week, dozens of new American bombers arrived in England. Every month, hundreds. Losses that should have crippled American bombing capability for weeks were replaced in days. The Luftwaffe confronted increasingly massive formations of well-equipped aircraft. Groups of 500 bombers became routine.
Then 700, then 1,000, fully supplied, fully armed, and replaced within days of being shot down. By 1944, American production figures revealed that Willow Run alone was producing aircraft at rates that matched entire national industries. The plant's output of finished airframes approached the total production of some Axis nations. German fighter pilots who had felt confident in 1943 grew progressively desperate by 1944. They were destroying bombers, yet every bomber lost was replaced by 2 more. Every pilot killed was replaced by 3 more. The Luftwaffe experimented with new tactics, superior fighters, and rocket weaponry. None of it altered the underlying arithmetic. American factories produced faster than German fighters could eliminate. By late 1944, the air war over Germany had decisively shifted. The relentless flow of replacement aircraft, trained crews, and equipment overwhelmed German defenses through sheer industrial capacity. Charles Sorensen never witnessed the final victory. He retired from Ford Motor Company on March 13, 1944, as he and Henry Ford had planned since 1941. His departure came just as Willow Run reached peak production. Sorensen had devoted his entire adult life to Ford, 39 years, beginning as a $3 a day pattern maker, rising to vice president of production, designing the assembly line that transformed manufacturing, and planning Willow Run, which proved aircraft could be mass-produced like automobiles. After leaving Ford, he became president of Willis Overland Motors, guiding the company's transition from wartime Jeep production to civilian automobiles, including the Jeepster, a sporty vehicle derived from the military Jeep. He clashed with Willis board over company direction but retained a title and salary as vice chairman from 1946 until fully retiring in 1950. After which he moved to Florida and the U.S. Virgin Islands. Sorensen owned extensive land in Cuba, seized after the Cuban Revolution. He died on August 11, 1968, at Bethesda Naval Hospital in Maryland, aged 86, and was interred in Miami Beach, Florida. He outlived both Henry and Edsel Ford. His obituary noted his role at Ford Motor Company, the assembly line, and Willow Run, but few recognized that he had fundamentally changed how wars could be waged, not through brilliant tactics, but through overwhelming industrial production. Mee Bricker, who succeeded him at Willow Run, remained until production ended. The last B-24 departed Willow Run on June 28, 1945, named the Henry Ford. It flew 3 months after Germany surrendered and weeks before Japan capitulated. Total production reached 6,792 complete aircraft built and flown from Willow Run, plus 1,893 knockdown kits sent to Douglas Aircraft in Tulsa and consolidated in Fort Worth for final assembly, a combined total of 8,685 B-24 Liberators produced. Over half of all B-24s ever built came from a single Michigan plant. These aircraft served in every theater: Europe, the Pacific, North Africa, China, Burma, and India, conducting anti-submarine patrols over the Atlantic, strategic bombing over Germany, island-hopping campaigns in the Pacific, and long-range reconnaissance. The B-24 operated in more roles and locations than any other American bomber, boasting greater range than the B-17 Flying Fortress. It could fly farther, carry more bombs, and reach targets beyond the B-17's range, making it crucial for Pacific operations where targets were separated by thousands of miles of ocean. In Europe, B-24s flew from bases in England and Italy. The 15th Air Force, based in Italy, operated primarily B-24s, bombing oil refineries in Romania, aircraft factories in Austria, and rail yards in southern Germany. Meanwhile, the 8th Air Force in England deployed both B-17s and B-24s against northern Germany and occupied France. The most famous B-24 mission was Operation Tidal Wave on August 1, 1943. 177 B-24s attacked Romanian oil refineries supplying a third of Germany's fuel. The raid was a tactical disaster. 53 B-24s were lost, 660 airmen were killed, captured, or interned, and 5 men received the Medal of Honor. The refineries were operational again within weeks. Yet the mission demonstrated the B-24's capabilities, flying nearly 2,000 miles round-trip to strike one of Europe's most heavily defended targets. In the Pacific, B-24s closed the Atlantic Gap, the mid-Atlantic region where German U-boats previously operated without fear of air attack. Aircraft based in Iceland or Britain could not reach it. American aircraft based in the U.S. could not reach it. Very long-range Liberators changed that. B-24s, stripped of some armor and turrets to save weight, were fitted with extra fuel tanks, enabling them to patrol farther than any other aircraft in 1942 and early 1943. They located surfaced U-boats and attacked them with bombs and depth charges, earning the nickname Terror of the Atlantic. A U-boat could submerge in 60 seconds, but a Liberator on the surface eliminated that advantage, equipped with radar to detect submarines at night, in bad weather, and beyond visual detection. By mid-1943, the Atlantic Gap was closed, dramatically reducing Allied shipping losses. The U-boat threat persisted but was contained. Long-range Liberators made that possible. Units such as the 8th Air Force's 44th Bomb Group, the Flying 8 Balls, arrived in England in November 1942, flew 343 combat missions by war's end, dropped 18,980 tons of bombs, lost 192 aircraft, and claimed 330 Luftwaffe fighters destroyed. 93rd Bomb Group, traveling circus, flew B-24s from England and North Africa, conducting the first B-24 bombing of Germany, including the Ploiești refineries, and missions from North Africa against Italian targets. The 15th Air Force's 49th Bomb Group, based in Italy, bombed throughout southern Europe and the Balkans, targeting oil refineries, aircraft factories, and transportation hubs, completing 396 combat missions. Every one of these groups flew Willow Run B-24s. Monthly deliveries from Michigan replaced losses and expanded new squadrons, keeping combat units at full strength despite heavy casualties. The impact on the war was immense, not just for the bombers themselves, but for proving mass production worked for complex weapons.
Willow Run showed the Pentagon that America could produce anything at automotive speeds: tanks, trucks, aircraft, ships. Capacity was not the limitation, design was.
This understanding transformed American military strategy for 75 years, demonstrating that wars could be won through industrial output, not solely superior tactics or technology.
America would prevail by producing more weapons than the enemy could destroy and replacing losses faster than the enemy could inflict them. Willow Run proved it could be done. Post-war, the plant changed ownership, passing to Kaiser Frazer for automobile production, then General Motors.
Some parts were demolished, others repurposed. The final assembly bay, where completed bombers rolled to the runway, was preserved. In 2013, a campaign saved part of the original plant, with the Yankee Air Museum acquiring approximately 175,000 square feet, less than 5% of the original facility, including the end of the B-24 assembly line and the famous bay doors. Today visitors can see where workers assembled bombers at rates aviation experts had deemed impossible and where Charles Sorensen's hotel sketch became a tangible symbol of American industrial power. Yet the greatest legacy is the lesson: mass production can defy conventional wisdom. Not through minor improvements or clever tactics, but by fundamentally reimagining possibilities, applying methods dismissed as impossible, and proving them feasible at scale. Sorensen sketched Willow Run in one night because he saw beyond what aviation experts knew. They believed aircraft could only be built slowly by skilled craftsmen.
Sorensen understood that anything made by humans could be standardized, systematized, and mass-produced.
Experts said no, too complex, too many variables, too much precision required.
Sorensen did it anyway.
He broke every aviation convention, invented new methods, solved previously intractable problems, and ultimately demonstrated that one bomber every 63 minutes was achievable. Production results that experts had called impossible became reality, showing that innovation in war comes not through committees or conventional wisdom, but from individuals who identify problems, find solutions, and refuse to accept limitations.
Edsel Ford did not live to see peak production but witnessed enough. He saw the plant in operation, saw production rates climb, and saw America's promise fulfilled. The cost was his life, stress and pressure from constant battles with Consolidated, the government, and his father likely accelerated his cancer, leading to his death at 49. His family never forgot. His son, Henry Ford II, who assumed leadership in 1945, ensured every young engineer understood that the most significant achievements require impossible commitment, that changing industries means challenging every assertion of impossibility, and that being right does not make the battle easier. For the workers who built those bombers, Willow Run meant employment, paychecks, and purpose, often protecting loved ones in uniform. For bomber crews, each Willow Run aircraft represented survival, replacements for losses, and reinforcements for understrength squadrons. The constant pressure eventually eroded German defenses.
For Charles Sorensen, Willow Run was vindication. The automotive production expert, dismissed by aviation authorities, constructed a factory that transformed how America fought wars.
Mass production proved effective for any human-designed object.
One factory, a mile-long assembly line, over 8,000 bombers in 3 years, one every 63 minutes at peak output, achieved using methods aviation experts said would fail. Producing results declared impossible, Willow Run stands as proof that innovation succeeds through vision, determination, and relentless execution.